This video is about factoring a trinomial of the form ax squared plus bx plus c with the product sum method when a is not 1, and this a refers to the leading coefficient here. So here's an example in the form ax squared plus bx plus c where a is not 1. And so what we're going to do is first of all identify a, b, and c. A is the coefficient of the x squared, or the squared variable, whatever the letter is. In this case, that'd be 6. B is the coefficient of the plain or single x variable, in this case 17. And C would be 12, the constant on the end. So the product sum method works like this. The product is always equal to A times C. So 6 times 12 would be 72. And the sum is always equal to the b value, so in this case 17. And now we play a little game where we try to find two numbers whose product is 72 and whose sum is 17. And so thinking about this may take a little while depending on the numbers, but I think 8 and 9 are numbers that will work. 8 times 9 is 72, and 8 plus 9 is 17. So now that we know those numbers, since a is not 1, we have to also incorporate the grouping method with this. So what we're going to do is this. I'm going to rewrite the original expression, except instead of writing the original middle term 17x, we're going to split it up into two different like terms, which are using these numbers as the coefficients. So here I'm going to say plus 8x plus 9x and then plus 12 on the end. Okay, so to be clear, there's the 8 and there's the 9 that we got from the product sum process. And if you think about it, 8x plus 9x is 17x. So they're like terms that would combine to this original term, meaning we're not changing the values of this original expression. We're just splitting it up in a strategic way. And what we'll do now is, since we have 4 terms, we're going to use the grouping method. So I'm going to group the first 2 and the last 2 terms. And the grouping method says factor each group individually. I can pull a 2x out of the first group as its greatest common factor, which would leave us with 3x plus 4. And I can pull a positive 3 out of the next group, which would leave us with 3x plus 4. And so, as you may know from the grouping method, since these parentheses match, we can factor them out of this full result, which would give us 3x plus 4 times 2x plus 3. And that's in factored form from this original trinomial. Now let's do another example that may be a little more difficult. In this case, let's do negative 2a squared plus 3ab plus 5b squared. So in this case, it's a little more difficult because there are two variables and the leading coefficient is negative. It's always a little bit nicer to factor a negative out so that your leading coefficient is positive. It's not completely necessary every time, but it usually does make the process easier in general. So I'm going to do that by factoring a negative or a negative 1 out of all of these terms. That would leave us with 2a squared minus 3ab minus 5b squared. And now inside, since the leading coefficient is positive, I'm going to go ahead with the product sum method. So again, let's write out a, b, and c over here. A is 2, b is negative 3b, and c is negative 5b squared. So, like you may have seen before, if you have two variables, you have to pick one as the main variable. And in this case, we're picking a to be the main variable so that this matches the descending order of powers you see in this standard form up here. So a squared, a, and then no a, which means b is just along for the ride as part of these coefficients a, b, and c. Now the product sum method works like this. The product is a times c, which in this case would be negative 10b squared. And the sum is b, which in this case is negative 3b. Okay, it's also kind of confusing because this happens. the letter in your particular problem happens to be the same as a letter used in a formula. So be clear that this b is not the same as this b. These are the a, b, and c coefficients from this form. These are the b's in our actual problem. All right, so the product sum will work just like it did up here above for us. And so this time the two numbers that work, and again we're just focusing on the numbers first, that add to -3 but multiply to -10 would be -5 and +2. However, since we actually have extra variables here, and we don't want -5 and 2 because they don't actually multiply to -10, we have to add the variable b with these two terms, so that when you multiply them together you get the b squared, and when you add them you get -3b. Now we'll take these two terms we got from the product sum method and go back to rewrite our original expression, except instead of writing the middle term, just like last time, we're going to split it up into like terms using these two expressions we got here. So those two terms are going to have to be -5b. However, they have to be like terms with this, so a has to be included as well. The 5b part came from over here, but they have to be like terms, meaning we need the a, and then we'll also put plus 2b a. And you can write AB or BA, the order of those doesn't matter. And then the last part we'll just bring down as -5b squared. Now we'll go ahead with the grouping method since we have 4 terms. And leaving the negative side out front, we can factor an a out of this first group, which will leave us with 2a minus 5b. And we can factor a b out of the next group, which would leave us with 2a minus 5b. And now these parentheses match, as is expected with the grouping method, and we'll factor those out, leaving us now with the negative sign still in front, and then 2a minus 5b, and then whatever was not in parentheses before then, a plus b. And this is our final factored form. So these are two examples of factoring with the product sum method when a is not 1. That's the leading coefficient.